Right, so now that we know what the problem is, we will first try to define our heuristic function and then we'll proceed with the state space tree. So like your greedy strategy, where for every problem you had multiple possible greedy choices, a heuristic is also in one sense you can think of it like a greedy choice, right? So it is some strategy you develop to give you an answer. It need not be the best solution like we saw in the previous segment, but it just has to be a valid solution. So a heuristic is also something like a greedy choice, not exactly the same but something very similar. So why I am saying this is, for any given problem there are multiple possible heuristics which you can use. So if you take the knapsack problem for example, any of the greedy choices, heaviest item, lightest item, profit by weight ratio, any of them is a heuristic which will give you a valid answer. Similarly for this problem, again there are multiple heuristics. One thing you can do is, for every worker you see which job he or she is charging the least amount for and you assign that job to that worker and you proceed. So for example, if we go back here, worker 1 is charging the minimum for job 2, so you assign that to him. Then you move to worker 2 charging minimum for job 3, so you assign that to them. And then when you come to worker 3, this person is also charging the minimum for job 3, and this minimum is a better minimum as compared to this one is even less expensive. So ideally if we had assigned job 3 to worker 3, we would have been able to bring about more reduction in cost. But because we already put job 3 in worker 2's hands, now we have to look at the next minimum, which is job 1. You assign that, and then worker 4 will get the only remaining job, which I think is job 4 if I'm not wrong. So that is one greedy choice or one heuristic you can use. For every worker you see which job he or she is charging the smallest amount of money for, and you assign that job to that worker. But the problem, like we saw in this example, is there might be multiple workers who charge minimum for the same job, and if the second worker's minimum is better than the first worker's minimum, then when you have already assigned the job to the first worker, you are in a spot of trouble. So this is a greedy choice. We can still go ahead with it. This is as a heuristic, it will still give us an answer, but can we do better? Can we think of some other heuristic, some other strategy which will give us a better bound? So instead of looking at it worker wise, what if we go job wise? So for each job you see which worker charges the least, you assign that job to that worker, and then you go to the next job next and you check from the remaining workers and so on. Now I will not go into the mathematical proof for this, but intuitively it is not very difficult to understand that this is a valid, sound, reasonable greedy choice, because ultimately you want all 4 jobs done. So for each job you are going to choose whichever worker is charging the minimum. And how we are going to do this is, we are not going to go about in J1, J2, J3, J4 sequence. We will look at the entire matrix and choose the global minimum. So if you take the example of this matrix, J3 worker 3 is the minimum of all minimums. So we will assign job 3 to worker 3. Now we will delete this row and this column because this worker has been given a job. This job has been given to a worker. We will take the remaining elements. Again we will take the global minimum. So what exactly we are doing here is, for every job we will assign it to whichever worker is charging minimum for that job. But when I say for every job, I am not going to go in the sequence job 1, job 2, job 3, job 4. I will at every step pick out of all the jobs whichever job has the least minimum. So if you look at job 3, the minimum charge is 1. If you look at job 2, the minimum charge is 2. For job 1, the minimum is a 5, and for job 4, the minimum is a 4. So your minimums are 5, 2, 1 and 4. Now you take the minimum of minimums, it is 1. So that corresponds to job 3 worker 3. So you will do that assignment. You remove that row and that column. You have again 3 workers, 3 jobs. Again you take the minimum of minimums and you continue. So why is this reasonable? Because at every step we are picking the global minimum, not a local minimum. So we know we cannot do better than this. So this heuristic is likely to give us not just a solution, but probably the optimal solution if we use it right. So this is how we define the heuristic function. How do we use this? We will look at it soon.